Hey YouTube, it's Dimitri, and today we're going to talk about the 2022 Fancy Quant PC build. It was a $2,000 project. I was actually targeting like $1,200. Turns out couldn't do what I needed for $1,200, so we ended up splurging up to about $2,000. Before we get going though, there is no sponsors in this video. Everything, every part, every brand is just me picking stuff out. I'm going to mention some websites too. Again, they're just what I use. It's not like I'm being paid. There's no connection between us at all. It's just me being me. So to start off with here, when you build a PC, you always have to have some sort of PC building goal here. Don't go out and think I'm going to build a really cool, awesome, fast, amazing PC, because you're always going to find like, I just need like a little more power. Like if I upgrade this part just a little bit, it'll be a little bit better. And then you upgrade this other one a little bit and it's a little bit better. And then you find out you go from like a $2,000 build to like a $12,000 or $18,000 build. And yes, I know that sounds insane, but when you start to see how expensive some of these parts are, specifically GPUs, which have been ridiculous because of all the Bitcoin mining and crypto mining in general, things get out of hand very, very quickly. So this build though came for a weird kind of reason here. My old PC was a Dell. I think I paid like $1,200 for it. I had it like 5 years ago. It has a problem. I think I know how to fix it now, but at the time I couldn't figure out what was going on. The PC itself kept just randomly shutting down. And no, it's not overheating. No, there's no malware. There's no software issues, viruses, any of that. Did extensive testing on that. I used to do this for a small firm. Was not that. It was something else, and it has to do, I think, with the startup. Again, I'm not going to go into too many details on that, but I needed a computer that wasn't going to just die. And I was shooting YouTube videos and I was doing, for example, interviews. And luckily, right, fingers crossed on this, none of my interviews got killed, but I did lose a bunch of YouTube content that I was shooting and then it would just die. And then it would, like, I don't know, I'm all off of my rocker here trying to figure out how to get back into where I stopped. So that was kind of happening. I was dealing with it for months, just trying to figure out which piece of hardware it was, which software issue. Has to do kind of with software, but more in the BIOS. Anyways, and I had the big interview coming up with Peter Carr, which has not came out yet, but it was coming up. I didn't want to risk, doing like an hour plus interview here. I try to keep them down to an hour, but, can go a little over, and then lose an entire hour just because my computer shuts down. And I was able to actually turn on or have like Word up, for example, and that prevent it from shutting down sometimes. And then it got so bad, it just killed everything. So anyways, we needed a new PC. I needed one very quickly. I did not have the time to research all of this in great depth, but I would have loved to have spent like months and months digging through hardware specs and building like my dream computer for the price range, but I didn't. So the goals for this PC though is build something quickly. I need something for video editing. So my PC needs are very different than most of yours in the quant data science realm. I do a lot of video editing for YouTube. I store terabytes and terabytes and terabytes of just stuff, from PowerPoints to video to audio to all kinds of random things that I need, like video clips and logos and all kinds of things. I run out constantly. Like I have like video cards, SD cards here, for example, and an SD reader, but I've got stacks of these cards just floating around and I'm constantly running out of space. And so for me, I have to have somewhere to put all this, and I have external hard drives on the floor. I think I have like 3 of them now. And for me, it's just chaos. Like it's hard to keep it all sorted, organized, and moved. So I need lots of space on my PC because I just store it all there. So just to kind of disclaimer here, I need lots of storage. This is like a big deal for me. Again, video editing though, you need good processors. So CPU and GPU are also beneficial because you need speed to process multi-tracks. So like, multi-cores and everything. It's important, but it's not like do or die. This isn't like gaming or like crypto mining or anything. I just need it to be decent to be able to actually edit. Simple coding. So I do simple coding, research and teaching, right? I do R tutorials. I do time series research, for example, sometimes, and test out ideas and learn all kinds of things on the side. I need decent processing for this, but nothing crazy, which we'll talk about at the end of the video. And then just daily usage, right? I use this for, web browsing, and I use this for putting together PowerPoints and writing documents and signing, legal forms and things like that. So again, almost any computer can do that, but the video editing and the coding is going to be a little bit more strenuous on the processing speeds. And most importantly, I hate waiting for computers. So there's kind of that as well, right? No one likes to sit and wait. And I've had crappy PCs in the past where I've cheaped out for corporate reasons, trying to get something good, and it just took forever. So this PC though, the goals that we are not shooting for, we are not building a gaming PC. Okay, if I was building a gaming PC, this would be like a $5,000-$6,000 PC because as you'll see, GPUs are ridiculously expensive at this time. I have an Xbox S1, I've had it for a long time. No, I don't have the newest gaming consoles. I have a Switch, I have an NES, I technically have a Wii, an N64, a Dreamcast, and maybe a few others. It's hard to remember off the top of my head. Oh, PlayStation 2, for example. Anyways, I use gaming consoles for actual gaming. I'm not building some crazy lightning fast gaming PC. I am also not algorithmic trading. I'm not doing implementation for any sort of corporation or trading patterns. I'm not building models at home that are being used in practice with massive data sets with like, I don't know, 100 million observations and 80 gigabytes. I'm running these things through processors. No, we're not doing that. If you were actually doing a trading thing and you wanted to do it on your own, you need to build a server. You need to optimize. All big banks use servers. I'll put a note here too. You could use the cloud. It would get quite expensive though. NVIDIA's DGX1 is a better option for doing algo trading, for example, if you wanted to do that. I think it's like $129,000. So apples and oranges here, right? We're not even in the ballpark of comparing these. Again, you just buy or build your own server. You could build one too as well. That's not what this goal is, right? I'm not using it for algo trading. It's just not what I'm doing. So the easy way to build this is you start running into compatibility issues, and I'm reading forums online on what's compatible, what works well together. I'm not a hardware expert or anything, but even just like basics, for example, like what chip you use, whether you're using AMD or Intel, the design of the chip, which side, so whether the board or the chip actually has like the needles that go out that actually need to go into the other piece. They're backwards on the two. So there's different boards, different things that are compatible that you need to think about. Again, Newegg here makes this all easy because you can use their website. So newegg.com, they have a custom PC builder. They have recommended PCs. You can just click and kind of get something that's kind of there. I believe you can pay like $99 and have them like assemble everything to on site and send it to you. I just had all the parts built through this process. I custom did this where I picked and choose all the different pieces that I wanted or needed. And then it actually narrows it down here. So just as a screenshot here on the right-hand side, you start off with the CPU. Then they give you a list of motherboards that are already compatible. You pick that. Then you go through like memory, then video cards, cases, power supply, storage, and all that. They narrow it down though, so you can't pick something that's not compatible. So I use this just because it's easy, right? I'm not a computer, hardware, software expert. I was out of time. I was trying to hurry through this as fast as possible to build a PC because I had this interview coming up and I had other interviews I was planning on doing, which got delayed. Anyways, it's easier just to use this than it is to do it by hand. Newegg also sells you all the parts, so it just makes it quick and easy. In general, though, this is the process. So again, all these logos are from Newegg's website, just to give you kind of an idea here. You pick out the CPU, the motherboard, the memory, the video cards. Then you pick out your case, your power supply, your storage, your CPU cooler, and finally, the operating system. I'm going to go just through the CPU here in a second. Motherboard needs to be compatible. Memory, I think memory is super cheap, so I try to buy as much memory as my motherboard will hold. Video cards are extremely expensive. Cases, again, I have a fancy one with like lights and everything. I don't really care. Yeah, it looks kind of cool, but I really wanted one with good ventilation for a decent price, so I ended up doing that. I believe I have a 750 watt power supply. That is more than I need. Newegg actually tells you to the expected wattage of your system, and so you can take that into consideration. I would buy something a little bit bigger though, because if you end up swapping out graphics cards or something else later in the future, you don't want to have to swap that out and then buy a new power supply unit or PSU. So those are kind of the things to think about. These are the general parts that you would need to go through a computer PC build process. This is really the order you should go about doing them. I trust Newegg, right? This is the process you would do to make sure you have compatibility. You're not swapping parts a lot. And these are the parts I use for the builder. So the motherboard is an MSI Pro Z690A with Wi-Fi. For me, I just wanted Wi-Fi. You can get a Wi-Fi adapter if not, but for me, just had that built in. CPU, I chose the Intel Core i7 12700KF. We'll talk about that here in a second. CPU cooler is the Thermaltake. I think I have Thermaltake listed. It's Thermaltake, not Thermaltake. TOUGHAIR 310. This got decent reviews. Again, on Newegg, you can see the egg ratings out of 5 eggs. I went online, did some quick research. This probably is not the best one. This is an air intake, though, versus a liquid cooled. It's a whole other process. I just feel like it's more complicated to put together. I believe they're more expensive as well. I'm not really running a lot of crazy stuff on this, and I'm not really going to be overclocking, though I could do that. RAM, though, I did CORSAIR Vengeance RGB Pro 4x8 GBs. So I have 4 slots on my motherboard. I got 8 gigabyte sticks, and now I have 4 of them. So that gives me 32 gigabytes of RAM here, which is decent. Again, GPU, we went with the MSI Ventus GeForce GTX 1650 with 4 gigabytes, which is decent performance for video editing, decent performance for like coding and data and whatnot. It is not stellar though. This is not like an all-star, but it is far better than like a 1050, for example. And I'll show you here in a second. You can go to a website, you can benchmark them and see how good they are and look at the pricing. Hard drive, this is where the big criticism from many of you has come, which I'll discuss here on the upgrades a little bit. I wanted something massive just to get going here. So I did the Seagate IronWolf 8 terabyte. Even 8 terabytes, I feel like it's kind of small for what I'm doing. But cost-wise, trying to keep this into perspective, that's what we ended up going with. The PSU is a Seasonic Focus GX 750, so 750 watts. That's way more than my system needs. It's not crazy big. You could go to like 1,000, which I think would be way too much for what you're doing here, but it's enough if I wanted to swap and upgrade GPUs. And then the case is an Antec Dark League DF600 Flux. It has fans that go from front in the front, 3 in the front. It's got 1 in the back and has 1 on the bottom that's pulling hot air out of the PSU and through the back. From reviews, it looks like it's a really good case for a beginner, decent build, fairly cheap. No, it's not going to be like the world's craziest airflow diagram. I even watched a video on how like it's okay, but it doesn't really do much. The fan that pulls the heat off the PSU. But I like that it has these magnetic covers on it. So let me grab one. I like that it has the little screens with magnets around the edge. And apparently it makes it not cool as well, but it prevents hair and dust from going in as much. I have 2 cats, so that's a big thing for me. Having that's pretty just like nice to have on the different vents. And then finally, it comes with Windows 10 as what you get. That's all you can buy. You can't buy Windows 11. I got Windows 10. And then, of course, Windows 11, they automatically give you, after like a week or something, it's like, hey, you know, please upgrade to the new operating system. So that's what I did for this build. Again, it was right around 2,000. It was like 1,900 and something with shipping and taxes and all that. But I think it's a decent build for what we're doing. Again, I could have probably made this even better if I spent more time like fine-tuning and looking at other parts for value and performance here. But this is what we ended up building. I just want to talk briefly about CPUs because CPU is probably the most crucial piece of the build along with the GPU, which I'm not going to talk very much about. But for CPUs, I looked at, for example, the i7. I looked at the difference between 11th generation and 12th generation processors from Intel. I'm not going to go into the whole AMD versus Intel argument here, but 12th generation, there was a massive jump in performance between 11th gen and 12th gen processors, which makes sense. As you increase the generations, there's just better technology, and typically it's a lot better value for what you're getting here. So I always recommend looking at, you can look at like the generation below where we're at. So 12th is the current one, but typically the most current one is going to have the best value and the best price, at least from what I have found. I looked at, for example, the i7 12700F. The one we used for this project is the i7 12700KF, which is the middle column. And then the last one, just to give you an idea, if you upgraded, want to get even better, it's the i9 12900K. So total cores here, 12 I think is more than enough for what I need. Been awesome to have 16. but I didn't do that. Number of performance cores though is 8 on all of these. A number of efficient cores is 4 on the 2 lower ends. Again, 8 on the i9. Total threads is 20 on the 2 lower ones, 24 on the highest one. There's gigahertz, which let me just get into this a little bit here. I'm not an expert. Gigahertz is somewhat the speed of the processor, but there are other things that impact this. So sometimes you'll see a chip that has a really high gigahertz read, and it might not perform as well as something that has a little bit lower one. So just because, for example, the middle one's 5 gigahertz and the one lower to it's 4.9, doesn't mean it's necessarily faster. It is technically, but when you typically run software, sometimes they're not as fast. Again, something else to look at though is look at like the performance core base frequency. Gives you a little bit better reading. Again, I'm not an expert on this, but you can go online, which I'll show you here in a second on this page, on userbenchmark.com, and you can benchmark CPUs and GPUs and really see the performance, and you can scroll through it. And you can see here on the bottom right, it gives you like the average score. It gives you the overclock score, tells you which one's better and by how much. And they do actual tests on all this. So this gives you a better idea of how they actually perform, not just glancing at numbers and saying like, oh, 5 gigahertz or 5.2. So I would highly recommend that. But none of these had integrated graphics cards, which was fine because I'm using a GPU no matter what. And cost-wise, this is where the big money maker is. The i7 12700F, the first column, was pretty bad compared to the 12700KF in performance and reviews and benchmarking. So, you know, getting like an extra $65, $70 to get up to the next one, I thought was worth it. But then, you know, the difference between the i7KF here and the i9K, going from 389, basically 390, up to like 614, that seems like a huge jump. And yes, the i9 is going to outperform the i7 here. There's no doubt. But cost-wise and value-wise, I just didn't see it being worth it what I'm doing here. Again, go to these websites. I have its CPU, but they do CPU and GPU, and there's all kinds of ones you can select and compare and contrast and all that. Do your homework, do your homework, do your homework. I can't say that enough. And then finally, the upgrades. The most obvious upgrade here. The SSD would be an extra $75 to $90 for 1 terabyte solid state drive, which is much, much faster. And as somebody pointed out, putting the operating system even just on that and then storing all my video on the traditional hard drive here would have been a really good idea. Now, it doesn't really blow my budget out, right? An extra 75 to $100 here. Like, it is what it is. I will most likely do this in the future. I was in a hurry. I just needed to get something up and running. Didn't want to tinker with all of this. So I didn't do it to start with. Now, this is extremely cheap for an upgrade. So this is probably what I'll end up doing in the future. I'll probably put a link in the description below. If not, you can kind of YouTube it. You can compare SSD and HDD. So standard hard drive, the solid state hard drives and the traditional hard drives. SSD, even like on startup, for example, on Windows, kills the traditional hard drive. So it is definitely worth it. The second upgrade, which I would like to do, but I probably will never do just because of cost, is upgrading the GPU to something like a 3080 or a 3090. There are other options out there too. Trust me, you can go and do your research and everything. But the current one I have is a 1650. It is $309, which is pretty cheap and fits right in the budget for a $2,000, computer PC build. But if I wanted to upgrade, for example, to a 3080, that's $1,609. That's a lot more. Or you could go all in with an Asus ROG Strix GeForce RTX 3090, and it's going to cost you about $3,300, which is more than my entire build here. So again, GPUs are just ridiculously expensive now because of all the crypto mining, which I'm not happy about, but it is what it is. So will I do that upgrade? Probably not. And then to wrap up this video quickly, right, what do you really need? That's the question I think you need to ask. A lot of times it's really hard to say like, do I need that little bit extra performance? Probably not. For students out there, you don't need a ton of speed. Gonna be honest with you. If you're gonna be doing R coding, Python, you're not gonna need it. Schools don't give you massive data sets to make you process and run all kinds of things. It's just not gonna happen. You don't need something crazy. I would consider, even if you wanted, you're on a budget, like an i5 processor line from Intel. Again, go on the user benchmark and stuff and look. You can usually find the one that's the best value, so a decent price with good performance and everything that performs fairly well. Students, you don't need anything crazy. So you don't need the $2,000. Like even what I have now, the $2,000 builders, it's not required. So no. Now, if you're running a firm, you would need a server. So I can't emphasize this enough. You don't need a little PC that you build online and it's got GPUs for gaming and all this. Now you're going to have issues with heating, and it's still not going to be as fast as a server, which big corporations are using. Again, you could use cloud. Cloud would be much, much better in this scenario. If you're a serious company, though, I have seen arguments for building your own servers because in the long run, I guess it's cheaper than actually using the cloud, depending on data usage, speed, and all that. Personal research, again, the one I'm using here is completely like awesome for doing personal research. You could even downgrade the one I have quite a bit. Research, again, you're not going to be using massive data sets. You're not going to be needing massive sets of power. If you're ignorantly just throwing in like huge data sets for the hell of it, like you're not doing it right. So a big shout out to those in data science who just don't do it right. You don't need something crazy, to be honest with you guys. Just build something reasonable. So if you need something fast, just buy something off the shelf. Buy Dell, Asus, HP, something like that, something pre-built. If you need it quick, you need it cheap. If you're a student, that's probably the route you're going. You might even need a laptop, which would be even easier to take to class. Just buy something pre-built that's a big brand. Now, if you're wanting something that's a little bit more expensive, but it's a little bit more reliable and it's easier to fix on your own, you want to get into PC building and learn a little bit more about the hardware side, I highly recommend building your own, right? You're going to get better quality parts because they're not mass produced as much in the sense that like Dell's just trying to generate as much profit as possible with this. Again, the average consumer is not going to want to spend a little bit more money for quality. So it makes sense to cut corners sometimes on just parts that don't really matter as much. So again, your Intel processors will be the exact same, right? Still Intel. But the motherboard, for example, might be a little bit cheaper, or like the RAM might not be quite as good. Again, I'm not an expert. It's just what I've read online. And then again, if you know the PC inside and out, you can fix your own PC much easier, and you built the whole thing and know all the parts and pieces. So it can just be a better option here. So anyways, that's my take. That was the PC build. That's why I built it, how I built it, and the upgrade of the SSD that I would do here. Of course, I could upgrade all kinds of things on this as well, from cases to cooling systems, but I don't think that's really that necessary. So anyways, thanks for watching. I hope you guys learned something new. And as always, until next time.